Welcome to Media 7 Academy. Today we are going to study about the domain and the range of the cosine and tangent functions. Okay, first let's take cosine function. F theta is equals to cos theta. So I'm going to draw a figure which we can use to understand the domain and the range of this function. You can see a circle. So let's take this point as O, the center point and the origin. Here y-axis, x-axis and the radius as r and this angle as theta. So first we need to discuss about the domain of the function. Domain is the set of values which we can substitute to the independent variable. So here the independent variable is theta. So we need to think about theta values. Simply when it comes to theta, you can substitute 65 degree, 90 degree, you can substitute 180, you can substitute 0 degree and you can substitute half degree even you can substitute 7/3 degree or 1000 degree, and also you can substitute negative values -1000, or you can substitute 100, -100, -60, -5, -half. Any value you can substitute fraction, you can substitute decimal value, or you can substitute negative, positive value, any value. Why? What's the reason for that? Because we are substituting values for this angle theta. So this theta can be any value into this direction, that means in anti-clockwise direction. When it comes to anti-clockwise, the value is positive. So this direction you can have any value, it won't be end, never end. You can substitute any value to theta, and also in the opposite direction also you can substitute values for theta, negative values for theta. So therefore the domain of this function you can have from -infinity to +infinity. So it's the same thing as the sine theta function. So df you can write that is from -infinity to +infinity, or you can write the set of real numbers. Then when it comes to the range, right, when it comes to the range, you can define cos theta as x coordinates of OP divided by OP, that we can take OP this length as R. And also I'm going to ask a question here, what is the maximum for x value and what is the minimum for x value? X max, that is equals, yes, you are correct, that is equals to plus R, and x minimum, it is equals to minus R. When you have theta here 180, that will be minimum, and when theta equals 0, that will be maximum. So here you have minus R. So therefore you can have x value is in between minus R and plus R. So you can divide all the terms by R. Now here what we have, -1. Instead of x over R, you can write cos theta, and here you have +1. So -1 here f theta, and that is less than or equals to plus 1. So that means we have the range as -1 to +1. So therefore you can write range RF is equals to -1 to +1. -1 to +1. So that is RF range, and we know the TF, that is set of real number set. Okay, now let's move to the next topic, that is the next function, tan theta. Tan theta. Now this was somewhat difficult to understand, not actually difficult, it is somewhat different from the earlier two functions, sine theta and cos theta. So here I will draw the same figure that will help us to understand the theory behind this domain and range. So I will take OP and here Y and x-axis. So first of all, let's have the domain, right? So what can we substitute for theta value? What can we substitute? We need to think about that. Right, so normally the definition of tan theta, that is y coordinates of OP divided by x coordinates of OP. That means normally we can write that one as y over x. But here x should not equal to 0. X should not equal to 0. But earlier we didn't write anything about r when r comes to the denominator. When we have cos theta, now we can write cos theta as x over r. But here we didn't write anything about r value because that is should not equal to 0, because we consider here a circle with the radius r. So r won't be equals to 0, right? There is the value for r. But when it comes to x and y values, x and y coordinates, there are some points that x coordinate can be 0, and there are some points y coordinate can be 0, because throughout this circle, x and y coordinates can be changed. So that's why we are writing here, when we are defining tan theta, definitely the denominator should not equal to 0. But now you should think about this theta value. Right, when it comes to 0, it's okay. Numerator will become 0, but denominator you have a value r there. But when you increase the value of theta, right, you can see value of y will be increased, and meanwhile the value of x will be decreased. And when it comes to this point, the value of x equals to 0. But from the definition we know tan theta, they should not have values which x becomes 0, right? So what is the value here when x becomes 0? That is 90 degree. Okay, keep it there and come to here. You can increase the angle of theta, then you can see x value, there will be x value in negative direction and y value becomes 0. It's okay, numerator can be 0. Okay, it's okay up to here. Then you can come to here again, right? So when it comes to again here, again you have x equals 0. So again you have x equals 0 at this point. So here angle is 90, right? Here angle is 180. Here that will be again 3 pi over 2. And again it comes to here, that is safety at this point 0. But when it comes to again here 5 into pi over 2, there will be x becomes 0. Then again here 7 pi over 2, again x becomes 0. That means we can have here odd multiples of 90, right? Odd multiples of 90, which gives us x as 0. But we cannot take those values for theta value. We cannot take those values for theta. So therefore, when we are writing df, the domain, we should remove these values. We should remove these values. What values? The values which x becomes 0. So there you can write from the real number set. All the other values are okay with it, but not the odd multiples of 90. From the real number set, you should subtract the odd multiple of 90. The odd multiple of 90. You should subtract. So this will be the domain. Right. Now what about the range? Now we have to think about the range then. Right. I will explain that one by using the definition. Now here we have tan theta equals y of x, and we know x should not equal to 0. X should not equal to 0. But yes, x should not equal to 0, but you can have a closer value to x. Not equal 0, but it can be closer to 0. Not equal to 0, but it can be very, 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 very close to 0. How? Like when x equal 0.00001, y can have any value. When it's like here, like this point, y can have a big value, which is very close to r, the radius of the circle, right? So then you can have very huge value for tan theta, because then tan theta will equals y divided by 0.0001. So that will be a huge value, right? So likewise, you can have a very, very close to a value which is close to 0 but not equal to 0. That means the decimal points, you can increase the decimal points like this, then you can have a huge value, a big value for tan theta. Same way, now that is when x is positive, same way you can have for the negative values in this direction, right? So there you can have negative values. So then you will have very big values for tan theta in negative direction, right? So therefore, the range or the result of y over x will be minus infinity to plus infinity, minus infinity to plus infinity. So there you can write Rf equals to minus infinity to plus infinity, because we cannot take x equals 0, but we can take a value which is very, very close to 0. Right, so that's it for today. I hope you enjoy the lesson. If you want to join our classes, you can comment below. So next day, we'll learn about rectangular Cartesian coordinate, about the trigonometry lesson. So see you next time. Goodbye.